Hi, my name is Rahul Debnath. Student number s1484804. I'm doing this assignment for Melbourne Polytechnic. Today I'll be demonstrating assignment 1, and I'll be answering some questions and also demonstrating how I could set up two different operating systems and how I could ping different operating systems and the networks. So first of all, I'm gonna open the assignment web page, and I'm gonna define some definitions so that we can better understand the whole assignment. The first one is I'll be explaining NRZ-I, which stands for non-return to zero. It is like a data encoding scheme which is used to represent binary 1 and binary 0. So as you can see on the diagram is when it goes up when it's going to represent 1, and then the wave goes down when it represents 0. And that's basically essentially the whole diagram. So the data themselves are encoded as the presence or absence of signal transition at the beginning of time. A transition of high to low at the beginning of a bit decodes binary 1. So if it goes high to low, this means binary 1, and if it goes low to high, that means there's like binary 0, and that's how it transmits data. So next on, I'll be talking about how multiplexing techniques with example and typical application. So what is multiplexing? Multiplexing is a technique in which several message signals are put together or combined into a signal so that signals can be transmitted over a common channel. However, some of the transmits, if you put all of the signals together, they are going to overlap, and there's a chance that they would get mixed up. So it is essential to keep them apart so that they don't interfere with each other, but also put the signals together. So how do we do this? We do it by explaining in frequency division multiplexing. So we change the frequencies of each signal so that each signal does not interfere with the other signals. That's basically, and we base that on different frequency or a range of frequencies for each signal known as a bandwidth. Example of this sort of multiplexing was during the old times when we used to have landlines. We used to call somebody and we would have cross connections because the frequencies would overlap, but nowadays, since they're all digital and wireless, that doesn't happen anymore. As you can see on the diagram, there's the how a frequency modulator works. There are three different signals coming from three different phones, and then the frequencies, as you can see, the frequency of the waves are different because they're far more spaced and apart from each other, and then when you combine all of them, they become one frequency, but they do not overlap before that, and therefore we have all unique frequencies for each signal. Okay, now I'm going to explain lossy versus lossless. The major difference between lossy compression and lossless compression is that the name says for itself. So lossy means when you compress a file or format into something, you lose some of it. It is usually something that is insignificant, like a noise. For example, if you were having audio file, and if you lose some of the file, it would be mostly noise or insignificant part of the file, so you wouldn't really lose much, but the quality does reduce. So even if it's a JPEG, which is like an image file format, or a video MKV, or even an MP3, if you compress them using those formats, the video will lose some of its quality, but it's so insignificant it usually doesn't really matter. But if you really are an enthusiast, you would want to have something that is encoded to a lossless format like a RAW or FLAC. FLAC is like an audio format that has zero loss when you are compressing it. So lossless means if you compress a format, it does not lose any data, and you can't compress it. It's exactly the same as it was from before. That's it for lossy versus lossless. Lossless data usually has way more space taken because obviously it has a lot more data. Lossy is usually used because it takes less space. So now we're gonna talk about virtual network. So I'm gonna demonstrate how we run two operating systems at once, technically three, because this is the host machine, which is the Windows, and I'll be running two more operating systems and showing you how these operating systems interact with each other. Thank you. I'll pause my Hi, so I'm back for part two. So my part two would be is to install two different operating systems using a hypervisor, which the hypervisor I'll be using is VirtualBox, which is a free open source software. And I'm gonna be using two operating systems and installing them on a virtual device and having them run against each other at the same time while having Windows as the host. So the operating systems I have chosen are the two most popular operating systems other on desktop other than Windows. So one of them is called Ubuntu, and the other one's called Macintosh OS or Mojave, the latest version that runs on Mac. So the first one is Linux based. Um, so this one is a very popular networking software or server software. This is running on it's just like basically running on Linux, and then they have this Ubuntu distro on top. Distro is like a different version of Linux specified for different purposes. There are many versions of Linux. And then we have the Mac OS. Well, Apple did not originally intend for Mac OS to be running on a Windows machine, especially on a Dell laptop. I'm not sure how much of that is legal, but for educational purposes, let's just say Apple should be alright. My system may be a bit slow because there's so much RAM the Mac OS is taking on. So for the first one, I'm just gonna start all over. So I'm gonna open my command prompt, and so my first task is to see whether the two machines ping each other. By ping each other, I mean whether the two machines can connect with each other, whether they recognize that they're on the same network and that there are other computers in the network. So what I'm going to try to do is try to ping Ubuntu with macOS, and they're both running virtual machines, as you can see, Oracle virtual machine, and then there's one here. And if you can see the bigger picture, hold on, there you go. So there's the two of the devices that are running at the moment simultaneously. So I'm gonna open up the command prompt on Linux, which is called terminal. So I'm just gonna scroll down, take that up, and look for terminal on here somewhere. Should be here. It's okay. Where are you? Terminal. Okay, so in that event, come on. Me. Oh, that's very specific. That didn't work. In that event, I just go up, then I just say activities, center, mail. No, there you go. Well, learning these new operating systems is a bit tricky. So there we go. We have the terminal, which is basically the command prompt for Windows. But the difference is the coding style is a bit different. So I'll be typing ifconfig to know what is the IP address of this particular machine, and you can see from the second line of the code, you can see that the INET or the IP address of the internet is 192.168.1.19. So now we're gonna go to the Mac OS and see whether this operating system can run on this one. Communicate with this one, because they're all on the same Wi-Fi network, which is the host computer, which is the Windows network. So I'm gonna go to Mojave. Maybe it's better if I do a full screen on this one. So I'm full screen on Mac. Okay, so I'm gonna open command prompt on this. So I'm gonna use Spotlight, and this is also called terminal here. Okay, so now I'm gonna say just gonna try remember the code for this. It was ip config. Yeah, sorry. So no, that wasn't it. So what I wanted to do was try to ping it. So ping, and then I would put the configuration of the first one, which is, okay, so I'll take that off, and then I'll go back to the IP address of this, which is inet, where was it? So 1.192.169. So 1.192.168.1.19, oh, 1.19, press enter, and as you can see, that is communicating with the Linux machine. And the best part about it is the macOS, when you ping something, it continuously runs in loop. So it's keep telling you that it's sending packages, and the time is milliseconds before it comes back to this operating system and goes pings. The ping is, it sends the data, goes to the operating system, comes back right here. So that's how long it takes. It will keep going on till I stop it. So I'm gonna stop that right here. So I've done the pinging part, and then I'm gonna talk about how we are gonna transfer files from one device to another. So for this, I'll be explaining two other more things, which is the bridge. A bridge is a type of computer network that provides interconnection between two networks, which is like two operating systems, or could be the same operating system. Bridge devices work at the data link layer of the open source interconnect OSI model, connecting two different networks together and providing communication between them. And then we have to talk about NAT. NAT is one way of remapping one computer's IP address to a different one, so that when they have the same IP address, it's easier to connect to the two computers if they have the same IP address. If I had to read it out, the definition form is a method of remapping one IP address into another by modifying network address information in the IP header of the packets, with basically changing the other IP address to the same one so that they can transmit data, traffic, routing device. The technique was originally used by a shortcut to avoid need to readdress every host when a network was moved. So you don't have to change the IP address all the time. It became popular and essential tool, and this has been used for a long time. So this network between two softwares, which is the operating system, can represent an operating system in a business or a home environment where there could be two different laptops or computers in a PC. So the first part of the bridge networking is very important, because this is what we are going to be using to be transferring files from one operating system to another, which is from Linux to Macs, using file transfer. We're actually using SSP. Sorry, what was that? It's similar to file transfer protocol, but so first we need to go to setting devices, and then we gotta go to Linux, we go to devices, and for the devices, let me have a look. Okay, no, so it was machines, was settings, and then you go to network, and then you set the bridge adapter like we mentioned. This is the same bridge adapter we mentioned before. So this is choosing this over NAT will let us have that connection with the other one. And we go to Mac and do the same. You go to machine settings, and then go to network, and then bridge adapter, and then we go back to share folders, and then we enable this share folder, which is in the host Windows, and the same one with Linux. Once we do that, I don't think we even need to do this, to be honest, but anyways, so just as a precaution, now after that we will try to go. So what I have downloaded is some profile pictures for me for my Facebook account. I'll show you. It's taking a while because it's so freaking slow. So this is some of the Facebook pictures I've had on my phone. and so I want that all these pictures transferred to the Mac. So what I'm going to do is I'm gonna close this. I don't even know how to close this. It's just the resolution is a bit messed up on this one, sorry guys. Okay, so I'll minimize this, and then you're going to go to properties. Sorry, actually just say local network share, and then I'm just gonna do that, and I've already clicked I already sharing it, so that's why the option is grayed out, but usually you click it and then you click on allow others and guest access, and then enable image test. And once I've done that, I'll go to my Mac, and so I will go to go up here, and then there is this option called connect to a server. So usually we can use FileZilla, but Mac OS has their own built-in stuff, and then we'll put on the address of the first Linux. So we could use FTP, but Linux uses SMB, which is apparently faster, and that's what we're using, and it seemed like the only way I could get it to work. So Rahul VirtualBox, which is the name of the first Linux PC, and the local means the local area network, and you just basically press enter, and it's trying to connect, and then it's gonna ask for the password, and I'll put the password of my own, the old one, or Linux one. Maybe just put it as guest, because I did operate as guest, and then it works because I put it as guest, and it finds that folder on the other Linux, and then press OK, and fingers crossed, and look, the pictures are right here, and you can even see that it shows up in network. And these are all the other all the other network PCs you can find, and I hope I could do this all right. Thank you for your patience. This is goodbye for now. Thank you.